Hey again! We're back on to evolution, GARSP. Specifically, we'll be covering some myths regarding evolution in general because this will explain a ton of the questions that people will have before they crop up in the actual stuff we'll be covering. And that way, when we go through how this all applies to world design, it'll make a ton more sense. So, since there's a lot of these, let's just dig right in. So, first off, natural selection is the only form of evolution. No, it's not. It's the naturally occurring variety, but we can have directed forms as well. Like, for example, dog and horse breeds. We didn't even know about genetics in the slightest when we started intentionally breeding dogs and horses for specific desirable traits. This follows the same concept as natural selection in that the creatures with the preferred traits for their environment breed more often, and therefore we get exaggerated features of one type or another. In nature, the desired traits aren't really chosen, more so just whatever you stumble across first by blind chance that works well in a given situation tends to proliferate at a faster rate than those without whatever that benefit happens to be. Shorter beaks better for cracking open nuts, and longer beaks better for reaching grubs inside of the hollows of a tree, for example. What happens to be handy is what you get. In this early form of genetic engineering, because that's basically what it was, we took like dogs which had a good sense of smell, and whichever dog was best able to smell out a fox, you'd breed that dog with others who also had a good sense of smell, and eventually you'd get a bloodhound who's specifically adapted to the task. In modern genetic modifying of stuff, we can isolate the genes which do what we want with a lot more precision than before and ensure they get used, while those that we don't want get removed intentionally. It's still basically the same concept though, as we need example reference points to know what works and what doesn't. Without a dog with a strong sense of smell, we can't really breed bloodhound equivalent genetically either without an enormous amount of additional research, which basically boils down to trial and error. In any case, breeding also applies to actual species mate selection as well. Things like the peacock, as a prime example, shows that natural selection can be overridden by the choices of individuals. A peahen picks a mate based upon how pretty the male is. More vibrant feathers and such is a real turn-on. Genetically, it's bad because it means you're more likely to die due to A, attracting more predators, B, having a harder time escaping predators due to way more weight being thrown into those tail feathers, and C, it costs way more nutrition to support the pretty display. Now this has the advantage as well of showing individuals as being stronger than others. If you can have that many penalties tacked onto you and still survive despite that giant bullseye around your neck, you must be pretty awesome. In this case, it's really not natural selection at work, which is more along the lines of how the peacocks with more pretty feathers tend to die because of the aforementioned reasons. So yeah, there's our genetically modified stuff, intentional breeding, and the choices of individuals as well. Plus there are also natural disasters as well. Natural selection makes you good for a given situation. But if that situation rapidly changes, like, bam, ice age out of nowhere, which happens pretty quick in only a few years as we've covered in prior episodes of Playing Goddess, then again, this is essentially an artificial change of the evolutionary path, even though the event itself may be natural in origin. Anyway, lots of different ways in which evolution takes place. Our next myth is that evolution always improves the creature towards its environment. No. As we mentioned with the peacock example just a moment ago, the evolutionary path they've taken specifically moves them away from being ideally suited to their environment. The key thing to understand is that evolution is based around the selfish gene mentality. Whatever produces a copy of the gene, as in children, is what gets carried on. The perfect adaptation to an environment that reduces the chances of breeding does not tend to survive long term in the gene pool. Now, on average, you will see a clear trend that things that generally make the creature, tree, or virus, or whatever better at surviving in their environment will tend to produce more offspring over time, and therefore tend to be more pronounced in the gene pool. But it's only a generalized trend. Evolution is not a consistent forwards motion. You have to keep in mind it's random and erratic, and most of the changes are either useless or go off on random tangents. Those that are actively harmful do tend to disappear. Those that are beneficial tend to become more common over time. But a lot of it's just going to be random stuff that gets tacked on with no real noticeable harm nor benefit. And the fate of such will depend on if it just happened to also get tacked onto another trait which was beneficial or harmful. Let's see. Related and similar, but not quite the same, is the myth that evolution always improves creatures just in general. Again, not the case. Note that the biggest issue with this is the definition of improved. What is an improvement over what came before? In one of the examples last week, we came to the conclusion that lizards underground may lose their eyes. This improves the creature because the cost to grow eyes in terms of nutrition requirements was higher than what benefit they paid out. So, just because one creature may be better than another in some way, shape, or form, there's always a price tag attached, a cost incurred. And we see this in a lot of dichotomies, where good genes may sometimes be bad, or bad genes may sometimes be good. Look at humans. Some humans build fat very easily. Others build muscle easily. We think of people who gain fat easily as bad genes, but the thing is, in our history, this was a good thing. If you had a tribe of, say, 50 people, we'll say, then when it came time to a famine, well, you want most people in the tribe to build fat very easily. What little food there is, you want to keep as much of it as possible for reserves when food is scarce. At the same time, you also want a small portion of your tribe to build muscle extremely easily. That muscle is needed to hunt game and collect other forms of nourishment, but muscle has a very high energy cost. Those with lots of muscle need to eat way more than the people with lots of fat. So ideally, you only want a few very muscled hunters to get more food for everyone else, because if everyone grew muscle easily, it'd lead to most people dying of starvation. Another example in terms of nutrition would be super tasters. About a quarter of the world's population of humans have a much greater sense of taste and texture to other humans, and a smaller percentage are even more vastly enhanced at their ability to taste than others. Now, this is a really handy trait when it comes to things like poison detection. If food's even a little bit off, it's much, much easier for a super taster to recognize this, and they'll tend to want to avoid it. Unfortunately, there are drawbacks with such as well. This same super tasting dealie leads to people who have a very narrow diet due to tastes and textures being amplified so much beyond what normal people taste, paired with being much less likely to eat things that are even a little rotten, and you find that these super tasters would be much less well nourished under normal conditions. But at a time when everyone else is horribly ill and barely able to move due to food poisoning, these same individuals would tend to be relatively unscathed and able to take care of the others. As such, it's really hard to say that a creature is genetically just improved by having certain genes or traits, because there's pretty much always something that's being given up in order to gain that benefit. And sometimes those situations may not be readily apparent most of the time. Like, until everyone's sick from food poisoning, the concept of the super taster doesn't even make sense as being a benefit at all. Heck, my last ex could barely eat much of anything. He had an extremely limited palate of what he could stomach at all. But you could pretty much guarantee that he was probably never going to get food poisoning off of almost anything. Anyway, our next myth is that microevolution exists, but macroevolution doesn't. These are terms which don't actually exist within science, but they do get brought up by people who don't really understand the concepts in play here. The basic argument is that, sure, evolution can account for small variations, such as like the finches in the Galapagos Islands having many specialized variations with differences to things like beak length and width and such, but the idea behind this myth is that these small changes can't alter an entire species. A finch will always be a finch, and can never have larger adjustments take place over time because evolution only works on a small scale. Well, that's the thing. Small changes take place over time in ways that you get little effects which pile up on top of one another until you're simply left with something that isn't what it used to be. Some of these changes are more difficult to understand than others. Instead of fully explaining this myth, let's actually move into the next myth, which furthers the same argument, since we'll be answering both of these when we cover the next one. And that next myth is the myth of irreducible complexity. This is an argument which is provided consistently by young Earth creationists, and the argument basically goes like this. There are some changes which are just so large and fundamentally complex that they can't possibly be broken down into smaller parts that are simple enough that evolution could ever have been the cause of such. The big case study that was given for a while was the argument that the bacterial Flagellum is irreducibly complex. It's a small little propeller tail type assembly in bacteria that allows them to essentially swim. The argument here was specifically that it's such an immensely complex and difficult mechanism to produce, and it's completely useless without all of it intact, and that there's no way that it could have been the result of evolutionary processes. And this is why creationist science isn't science. See, science is when you get to something you're like, I don't know how that could possibly happen. I wonder how I could find out. And then you devise tests and figure out ways to study it so that you can understand it. The creationist science basically goes, oh, therefore God. And that's the end of the argument. This doesn't mean that science and creationism are mutually exclusive. It's quite possible and even semi-reasonable that if you had some omnipotent, omniscient being, that they could very well have known how things would naturally evolve after setting up the rules for the universe. That's an argument for another time, but the point is that there's no real conflict between the concept of there being some sort of deity or even a pantheon of deities in evolution. But let's get back to this flagellum. I mean, it's really complex. Let's face it, it didn't all just magically appear all at once. Evolution doesn't work that way, so what happened? Well, once it was brought up as an example of irreducible complexity, other scientists were just like, that really is weird. How did that happen? And then they found that the flagellum is actually comprised of 3 much smaller, simpler component pieces, which all have perfectly legitimate and valuable uses elsewhere. And it requires almost no effort for these 3 to be built on their own independently of one another, nor for those 3 to then be formed together into a whole with minimal alterations. So it turned out that the flagellum wasn't irreducibly complex at all. In fact, we've never found anything which is irreducibly complex to the point that it couldn't be reasonably explained by evolutionary processes. Another good example of this is DNA. It's really complex. And in fact, it needs to also have things like proteins and mitochondria, which provide more complex mechanical instructions for how to do things with enzymes, for example, and raw power generation. You'd have to have all 3 of these develop independently. So what gives? Well, there's no argument in science that life began with DNA is the thing. It's not even a reasonable argument. No one's even postulating that such is the case. Instead, the belief is that the biogenesis of life on Earth, well, there were probably 2 biogenesis events actually, and that there are also some sulfur-based microorganism extremophiles, which probably weren't from the same origin point, but we're still studying that. Anyway, the biogenesis on Earth would have originated with RNA instead of DNA, which kinda sucks at DNA's job. It also sucks at protein's job, and the job of mitochondria as well. But the important part is that RNA can do all of these things independently by itself, even if not very well. Even more important is that RNA uses a simpler sugar molecule than DNA does, and is a single helix chain instead of a double helix, making it vastly easier to be created by chance. Other highly handy features of RNA are that it's way more reactive than DNA, as it's built in such a way that it can manage enzymes directly without needing proteins to perform those actions. This can be bad, as enzymes can attach to and damage the RNA or corrupt it, or they can enhance it and perform the role which DNA uses proteins for instead. Now, this is fine for smaller organisms, but it sucks really badly for large-scale multicellular creatures like humans. Another semi-handy feature is that RNA is not very stable compared to DNA, so instead of existing for a long period of time, it's created, then used, degrades, and gets recycled very quickly, allowing for a high turnover rate of genetic mutation, meaning it can potentially improve itself quicker than DNA can on a cellular level. With shorter, simpler chains, it's just easier to make and doesn't require stuff like mitochondria or proteins at all. But it can be used to produce protein. So it's a handy little thing, and is why a lot of single-celled organisms, like lots of viruses and such, still use RNA instead of DNA. It's not that effective compared to the later tools, but it can do everything needed in a very small space. Anyway, most likely, life began with RNA, and then these other things were gradually built up over time and replaced the RNA's functions one at a time as they were able to, until the RNA just became obsolete when all of its functions could be better performed by other, newer and more advanced tools. Then the RNA fell to the wayside as a primary source of genetic information, and instead was repurposed to programming amino acids and transforming information for protein production instead, and other tasks now that it was no longer needed to do the job that DNA took over because the DNA was better at it. So yeah, this is how irreducible complexity and macro versus microevolution don't really exist in reality. If you don't understand that there are alternate uses for things and that they can be built up to perform wildly different tasks, then repurposed later on, you're gonna get really confused and it's gonna look like it's impossible to exist. Wings, for example, are normally used for flight, but they're still useful even before you can fly. Same thing with feathers and hollow bones. The velociraptors of the dinosaurs have semi-recently been found to have had feathers, which don't tend to fossilize very well, but we've lately discovered that they did in fact have these features. So why? They couldn't fly? Well, those same feathers let a raptor jump on top of its prey, dig its talons into its back, and it could use them for stability, letting it stay latched on and biting and clawing at its prey without falling off or getting shaken free. Over time, the feathers grew more pronounced at being able to perform that action, and their arms grew longer for better stability, and oh hey, then they got repurposed when those same bigger wings and feathers became large enough to the point that they could be used to glide short distances, to swoop down on prey. And then they got repurposed again into proper flight later on when they specialized further to become better at gliding, which also just happens to make wings better at actual flight as well. Each step wasn't with an end goal of flight, but rather a more short-term, different purpose, which just happened to also be beneficial at another task later on after a certain point is all. So, yeah, moving right along. Oh, I accidentally covered a few other myths without trying with those examples. Well, those myths were going to be about how creatures couldn't evolve with DNA, which we covered under the RNA dealie, and the myth that creationism and evolution can't coexist. They totally can, though whether they need to or not is another question entirely. There's no reason there couldn't be some deity or pantheon of deities that exist. But there's no absolute need for them to exist either. That doesn't mean they don't exist, it's just that we don't need them to explain evolution. But evolution doesn't disprove their existence either. Anyway, well, let's just get into our final myth, since this is a really long video already. And that myth is a ridiculous one, but one that does come up surprisingly often. That evolution violates the second law of thermodynamics. The second law basically is that anytime there's a thermal reaction, entropy increases, or things just get more random and less organized over time, and new information can't be created without a source of energy to produce such. The argument basically boils down to the claim that random genetic mutations can't have any useful or valid information and can't produce anything new in general, because it would mean that they're reducing entropy rather than increasing it. This argument hinges upon the concept that there is no energy source present which is feeding new energy into the system to allow for increases to occur. Okay, do me a favor. Go outside. I know, it's anathema to internet geeks. Standard allergies include fresh air, natural sunlight, and social contact. But seriously, just go outside for a moment, or even to a window if it's during the day. Now look really hard. Is there anything out there which may produce energy? Anything at all? Something which may just add a bunch of energy to terrestrial plants and animals? It's called the sun. Yes, this argument hinges upon the fact that the sun doesn't exist. Since it's kinda obviously a ridiculous statement to make, yeah, that's not the case. Life couldn't exist without an external energy source, though. That much is true. Without something like the sun, geothermal heating, or some other form of large-scale energy input, evolution couldn't exist. But we have geothermal heating, chemical reactions, the sun itself, and so on and so forth. In a fairly basic example of this, the sun generates heat and light. Plants photosynthesize such into usable energy, and that allows them to use other materials to grow larger and to potentially alter their genetic code over time. Even earlier species, like the first single-celled organisms, would have benefited from the energy of the sun and geothermal heating, though not in the same way. Most likely, the biogenesis of life on Earth would have begun in a volcanic region with warm water. Yeah, heat from volcanoes and the sun again would heat the water up, and that would allow for things like the first amino acids, RNA chains, and so on to form. There wouldn't be much information present at first, but it would be possible to increase that due to the fact that there would have been those external sources of energy to that first single-celled organism, allowing it to grow more complex over time. So yeah, anyway, basically, we needed to cover this stuff before we got into the actual evolutionary processes in terms of world design, because we're going to be looking back on a lot of these same principles in the future. And it's just easier to get them mostly out of the way now so we can see them put into use without having to explain each one later on as they come up. There are some other concepts we'll need to include eventually, but those will be more easily explained by walking through the creation of an example ecosystem within the world design process. Stuff like how life will always find a way to eventually make use of food source. So long as food source exists, sooner or later, something will find a way to exploit it. Which means ecosystems naturally evolve to build multiple tiers of different creatures and plant types. You will pretty much always get some combination of plants, prey, predators, parasites, and carrion feeders, no matter what world you create, because they naturally produce one another. If one doesn't exist in an ecosystem, within a few generations there will be one developed, because there's simply a food source available to be exploited. But yeah, that's something we'll be getting into next time on Playing Goddess. For now, there's no real homework, but there will be soon enough, so get ready for it. Anyway, right now, I'm out. I'll see you next time.